Good afternoon, council members. This is so far the investigation of the community issue that we've been having. So the issue is, in the last few weeks, residents have noticed an increasingly large number of dead fish washed up onto the beach. And this area is routinely used for a variety of recreational activities, including swimming, surfing, boating, and fishing. And the local community is concerned about potential toxins in the water, especially since this could affect their health and the local tourism industry. So they've hired me to look into this issue and see what could be causing this. My thought so far is, as we all know, oxygen is always around us, bouncing in between air and water, and if one body is more crowded than the other, the oxygen will actually move to the less crowded. So say there's one too many in the water, it'll move up into the air, or if there's too much in air, it'll move down into the water. This is what balances the oxygen content. The example picture on the right. And this oxygen can be depleted with many factors, thus damaging aquatic life forms included. And my belief is that eutrophication is the lead cause in this damage. So what is this exactly? This is the excessive richness of nutrients in a lake or other body of water, frequently due to runoff from the land. And this causes a dense growth of plant life and death of animal life from lack of oxygen. And this is from high levels of nitrogen and phosphorus. As we know, chemicals are used in farmland, and when it rains, that goes into lakeways, which all leads back to the ocean. This damages the ocean by the depletion of oxygen by harmful algae blooms, which are these steps right here. So, nutrients enter waterways, nutrients help develop plant growth, algae blooms occur. This algae dies and is decomposed by bacteria. This kills off most of the oxygen. This decomposition of algae increases biological oxygen demand. This makes it harder for plants in the water to create photosynthesis and for fish to create oxygen to breathe. This will limit their growth factor, reproduction factors, and will make them suffocate from lack of oxygen. So as you see in step 6, this is fish and plants and aquatic forms all die. So this leads into dissolved oxygen. And as you can see from my little fact sheet here that I made, temperature is key when it comes to dissolved oxygen. The picture shows the temperature on the bottom and the dissolved oxygen on the left-hand column. And so this movement is rapidly moving water, such as in a mountain, stream, or large river. This tends to contain a lot of dissolved oxygen, or DO. The concentration of DO in surface water is affected by temperature and has both a seasonal and daily cycle. And unfortunately, DO is used by all forms of aquatic life. Therefore, this constituent typically is measured to assess the health of lakes and streams. We use it daily. Photosynthesis is the primary process affecting the DO temperature relation. Scientists measure this to measure how healthy waterways are for fish and for humans to be involved with. And so some interesting facts is the formation of oxygen-depleted subsurface waters has been associated with nutrient-rich nitrogen and phosphorus discharge from the Mississippi and Atchafalaya rivers. Bioavailable nutrients in the discharge can stimulate algae blooms, which die and are eaten by bacteria, which was mentioned previously, and this does deplete the oxygen in the subsurface water. And so if we go into the dissolved oxygen into the metabolic process for a fish, fish can survive in a dissolved oxygen environment in anything above 5 ppm, that is, part per million. When levels reach below 5 ppm to 2 ppm, fish can survive but are in high levels of stress and inhibits their growth and reproduction factors. And then once ppm levels reach 1 and under, the fish does unfortunately die from lack of oxygen. So this little fact sheet that I once again made, metabolic process and the breakdown. An aquatic system lacking DO is considered anaerobic, 0%. A range of 1% to 30% is considered anoxic. In low DO concentrations, there are two ways fish can respond. A secondary lamellae can open up to increase blood flow, or by reducing the blood plasma volume, which increase urine flow rate. Moving to lower temperature and reducing activity, reproduction and feeding, as well as protein synthesis. This means transcription is reduced, mediated by increased levels of hypoxia-inducing factor 1, which also upregulates genes involved in erythropoiesis, capillary oxygen homeostasis, and reducing energy expenditure. In this process, for a dissolved oxygen or DO-related fish kill to occur, a combination of environmental conditions transpire simultaneously. This could be weather patterns, water temperature, depth and quality, amount and type of plant growth, fish community structure, along with the presence of viruses and bacteria are all factors that are necessary to trigger a fish kill. Lakes, ponds, and canals located in residential areas are particularly vulnerable to the DO-related fish kills. Once again, any kind of chemical from factories, sewers, farmland, this all affects things, and unfortunately it's all human-related. Energy utilization is decreased, associated with a shift from aerobic to anaerobic metabolism. And what this can do inside of the fish is bubbles can form in the blood, and these can actually block the capillaries. So below I have a picture of a fish with the fish metabolism, just showing all of the things that can be affected with this dissolved oxygen environment. And hopefully that was informative for you.